The Arches cluster is located about 25,000 light-years from Earth, in the direction of the constellation Sagittarius, just 100 light-years from the center of our Milky Way. Due to its proximity to the galactic center, it is extremely difficult to observe, as galactic dust absorbs much of the visible light. For this reason, the cluster was only discovered in 1995. The proximity to the galactic center also dictates the high velocity of this object. Its center of mass revolves around the black hole at an incredible speed, exceeding 200 kilometers per s. The cluster gets its name from the extensive arches and loops visible in the X-ray spectrum, which are hot gas clouds with temperatures up to 60 million degrees. These arches form due to powerful stellar winds emanating from many stars in the cluster, with these stars emitting intense electromagnetic radiation that spreads in all directions, creating bubbles of gas that interact with the surrounding matter. This interaction heats the material, which begins to emit actively, forming bright arcs and loops. When several of these bubbles merge, their intense radiation and the small distance between the stars creates stable, arc-shaped structures. The Arches cluster contains about 135 young, bright, and very hot stars, which are significantly more massive than the Sun, as well as several million less massive stars. The absence of stars in later evolutionary stages indicates that this is a young cluster, with its stars being around 2.5 million years old. Unlike the quintuplet cluster, which has a comparable mass but is much older, the Arches cluster has not yet formed stars in the later stages of evolution. The quintuplet cluster already contains red supergiants, while the stars in the Arches are only just beginning to leave the main sequence. The Arches cluster is an ideal object for studying the upper mass limit of stars. With its density, which is directly related to the mass of a star with a mass of 400 solar masses could theoretically have formed there. However, despite the youth of the cluster, the most massive stars still visible are those with lower mass. Statistical studies show that stars of colossal mass could exist in this cluster, but no stars heavier than 150 solar masses have been found. This discovery has led scientists to reconsider the possible mechanisms that limit star mass, as stars with masses greater than 150 solar masses have also not been found in other clusters with lower density, except for some unique objects, such as the star R136A1 in the Large Magellanic Cloud, which has a mass of 315 solar masses. The Milky Way has always inspired people. It is not only our galactic home, but also a unique laboratory for studying the laws of the universe. Our position within the galaxy allows us to observe its structure and dynamics up close, while advanced technologies, such as high-resolution telescopes and radio interferometry, provide access to information about its past, present, and future. The Milky Way is a whole story, where the processes of star birth and death, the interactions of nebulae and supermassive black holes, as well as galaxy mergers, have left deep marks in its evolution. By studying the Milky Way, we not only gain a better understanding of our galaxy, but also broaden our knowledge of the universe as a whole. Questions related to the origin and evolution of galaxies, the nature of dark matter and dark energy, and the potential for life elsewhere in the universe. These topics cannot be understood without in-depth research of the Milky Way. In every corner of it, there are answers to questions that have intrigued humanity for thousands of years, and every new discovery opens new horizons for future research. Subscribe to the channel and stay updated to not miss the most interesting news about our galaxy and the mysteries of the universe.